I want to talk through a little bit of a review of Chapter 6 and Chapter 7 that will appear on your upcoming exam. Both of them have to do with normal distributions in some type of context. So these are usually some of the hardest questions for students to be able to differentiate between when am I supposed to do what? How do I know if I'm supposed to be using just the regular normal distribution or doing the central limit theorems, or what are those things? Okay, so this main question, this is the go-to question you need to ask yourself when you see these types of questions is, are you trying to find the probability / percents? I could ask them for either of these. Of data falling in a certain ranges when you're comparing this to a specific data value or a mean / sum of some sample. This is the major difference between these. So if I say you have a normal distribution for some set, you're trying to find what is the probability that you find a sample, or you find a data value that's larger than 80. In that context, I'm comparing it to a specific data value that is not referencing means, sums of samples. If I instead asked what is the probability that a sample of 9 people would be larger than 80, then you should be thinking the central limit theorem for means, because you, or sums, well, whatever. But nonetheless, because you're asking it about a sample and either a mean or a sum of a sample set of data, then you want to use the central limit theorem. So if you have a specific data value and you're trying to answer this question about percents or probabilities, first off, the set must be normally distributed. If it's not, none of this works. So there should be some claim in there about that. The steps you want to take, draw a normal distribution. You want to shade the region that you want. Remember, the mean always goes in the middle. Shade whatever region. Use the regular formula for z as a data value minus a mean divided by a standard deviation. In this case, because you're working with a normal distribution, the mean that I give you is the mean. The standard deviation I give you is the standard deviation. So that just gets plugged in. Then you use the handy-dandy chart because you have a normal distribution. So you'll find some type of you have the z-score. You'll use the chart to find the percent that's between the data value and the mean, and then you do whatever you need to get the answer. Maybe you subtract the numbers, maybe you add them, maybe you add 50, subtract 50, whatever it is, somehow get the right answer. Now, obviously, you could ask these questions with percentiles instead, and those you're going in reverse. So I give you something about, say, an 85th percentile. You then have to figure out what does it mean to be in the 85th percentile. So you have your normal distribution, and then you figure out, okay, I have the percent. I need to find the middle value in the chart, then find the corresponding z-score that I could plug in, solve for the data value, and then you're going in whatever reverse order to get the final answer. Now, if instead you said, wait, the question wasn't about a data value, one specific number in the data set, instead it asked about a sample and a mean or a sum with the sample, then you need to use the central limit theorem for either means or sums to describe the normal distribution. So remember, this is your central limit theorems for your means has the same mean. The standard deviation gets divided by the square root of n. And the central limit theorem for sums, you have this. Both of these formulas will be given to you on the exam. You don't have to worry about memorizing those. But once you have this, now you have a normal distribution. That is the power of the central limit theorem, is you take something that maybe isn't a normal distribution, you look at sample data, those form a normal distribution, then we do exactly what we did over here. So then we draw the normal distribution. The mean is going to be one of these two numbers, depending on which one you use. Then you shade the region. Again, you still have the data value minus the mean divided by the standard deviation. The only difference is that you have special means and special standard deviations that come from these expressions. Then you still do everything else the same exact way. The percentiles, again, you go and reverse the same thing, except you have these special normal distributions. So these two are almost identical, except for the very first step of figuring out what is the normal distribution that I'm using. Is it the original data set being normally distributed, or do I use samples and either means or sums to get these normal distributions, but everything else should work out the same exact way. So hopefully that helps clarify some of the most common mistakes with normal distributions and central limit theorem for sums and means.